Good morning and welcome to this first in our series of briefings today that will preview Space Shuttle mission STS-120. With us to give an overview of the Space Shuttle program and the International Space Station program is Space Shuttle Program Manager Wayne Hale and ISS International Space Station Program Manager for Mission Operations and Integration Kenny Todd. We'll hear from both gentlemen and then we'll take questions. Wayne?
Well, good morning, everybody. I thought the best way to start talking about STS-120 was to put it in a bit of historical context. You know, in just a few weeks, on October 4th, we will be celebrating the 50th anniversary of the first satellite, the start of space travel in the modern era. And it's important to remember where we've come from and to ensure we know where we're going. In the early days of the space race, as we called it then, it was a competition between the great nations of the world that allowed each of the great powers, and it took a great power, a rich nation, to participate in spaceflight in the early years, to show off their technological prowess. And in fact, that fueled the early years of space exploration. Today, I am pleased to report we are in cooperation with many international partners, including many of our former rivals and other allied nations, in a great expedition to build and complete the construction of the first permanent outpost in space, the International Space Station. This competition has evolved into a peaceful cooperation. I think it is a truly remarkable thing in the history of the world that we are engaged in what is one of the truly great building, engineering, scientific feats of the era of all ages right now with our international partners to construct this outpost, toehold on the fringe of space that will enable us to learn the things that we need to do to go on and explore space, onto the moon, onto Mars, not just to plant flags and place footprints, but to stay there and be a permanent presence in space and to expand the frontiers of humankind. And I would just note our congratulations to our Japanese colleagues on the launch of their lunar probe yesterday. It is a great step forward in the exploration of space. You know, for almost half of the space era, 26 years now, the Space Shuttle has been flying. And the Space Shuttle has turned out to be the workhorse, at least on the American side, although you could say for the entire world, the workhorse of space. It remains the only reusable spacecraft. It remains the spacecraft that can bring the most payload home from outside the atmosphere back into the Earth's surface. Almost 3/4 of all the people that have ever flown in space did so on board the Space Shuttle. And over half of all of the mass that has been put into Earth orbit by all nations, by all rockets for all time, has been put into space by the Space Shuttle. It remains a wonderful platform for construction, for repair, to stage spacewalks, to have scientific expeditions, and it remains a remarkable vehicle, however a fragile vehicle that we must be constantly vigilant to operate safely. So we are looking forward to the next step, STS-120, ISS Mission 10A, which puts up the Harmony node onto the International Space Station, the next large piece of structure, enabling the way for our international partner scientific modules. I'm sure Kenny will talk some more about that, to be added later this year. I would like to say that we have a lot of schedule margin to complete the International Space Station by 2010. As you know, we had a little bit of unfortunate weather early this spring that cost us about 3 months on the schedule. People frequently ask me, can we complete the International Space Station, the Space Shuttle's commitment, by the time the President and the Congress have directed us to retire the Space Shuttle? And my answer is yes, we have plenty of margin. We have been exploring a number of options that would allow us to fly flights more rapidly should we encounter some other unforeseen difficulty, say a weather situation like a hurricane or a hailstorm or some technical problem. Right now, we think that it will take us most of the time to 2010 to complete the space station, but we have a number of options to ease that schedule, potentially by using more bays of the VAB, potentially by flying Atlantis more often, a number of different options that we could execute that would allow us to take up any slack or any problems that we might encounter. So I'm very optimistic we will be able to complete the International Space Station well ahead of the goal date to retire the shuttle, and indeed to service the Hubble Space Telescope about this time next year as well. As an example of that, I would point out that on the last flight, as you're well aware, we lost another piece of foam off the external tank. And it caused us to go take a look at a new bracket that we had been looking at, but accelerate a fix for it on the liquid oxygen feed line brackets on the outside of the external tank. We were able to determine the root cause for that problem, apply a fix, and we are on track to actually fly on the scheduled date that we have always said we were going to fly STS-120 on. Because of the really rapid, flexible, creative, and hard work of the Lockheed Martin Machute Assembly Facility folks and the Marshall Space Center engineering folks that put that fix together. You know, we keep looking at the external tank as a source of foam debris, and it's inherent in the design of that tank that we will probably always lose foam off the tank. What we've tried to do is take a look at all the areas where we've had historical foam losses or where we could potentially have losses of foam and rank them in order of their likelihood to cause damage to the Space Shuttle thermal protection system. And we have been whittling away at that list, starting with the most dangerous foam losses and eliminating those hazards. And we're going down the list. But I will tell you that we will lose foam off the external tank to the very last flight. However, we are working on each of those areas so that we are mitigating the hazard, and the last tank we fly will be the safest tank we ever fly as we make a continuous improvement to that external tank. On the other side of that, of course, we had a lot of discussion about tile repair last flight, and you'll recall that we did not, in fact, need to repair the tile. Our engineering analysis proved rather conclusively, along with the test data, that we were safe to re-enter without applying a repair to the rather minor ding that we had in a couple of tiles in the aft of the underside of the shuttle. However, it did remind us that we need to sharpen our efforts again to improve our TPS, our thermal protection system repair capabilities. So yesterday at the Space Shuttle Program Requirements Control Board, I directed that we would add a day to the mission of STS-120, and we for the purpose of going out and demonstrating on orbit tile repair capabilities that we have been developing over the last several years. These are over and above the tile TPS repair capabilities that we had on STS-114 or STS-121, our two return-to-flight test flights. And they will demonstrate, I think, an improved repair capability and allow us to know with confidence that we can apply those repairs if they become necessary, and we certainly hope they don't. That plan to add a day and an EVA to do those tests will be reviewed jointly between us and the space station team at our joint meeting on Monday, and I think that we'll make a final decision to include that capability on the flight, if all goes well, to demonstrate additional tile repair capability. One other thing I should tell you about STS-120 is that it marks a new day in the way we do our flight readiness reviews for the Space Shuttle program. We have decided that we need a more in-depth review at the program management level before we go forward to the executive level at NASA headquarters, the associate administrator and folks at that level for our flight readiness review. So we have added a special review for the Space Shuttle program manager to have a two-day review at the Kennedy Space Center about a week before we have the executive level review. The executive level review has also been changed change, that we will add more independence to the panel that will review our readiness for flight and ensure that those of us in the Space Shuttle program have done our work properly to ensure that we have a safe and successful ahead of us. I think that's about all I've got to say this morning, so I'll hand it over to Kenny at this point.
Thanks, Wayne. Well, it's great to be here today with you discussing STS-120. For those of you familiar with the assembly sequence for the International Space Station, this is the flight that we refer to as Flight 10A. I'll explain a little bit more about the significance of this particular flight later, but before I did, I wanted to give you an update on our current configuration for the space station, as well as an update on our Increment 15 crew. Could we go to still number 1, please? This is the current configuration of the International Space Station. This particular photo was taken by the Endeavour crew during their departure from the ISS last month as part of the Flight 13A.1 mission. I particularly like this photo because it shows in very good detail the integrated truss structure that we've been putting in place and has been the focus of our assembly activities since really the launch of the S0 truss back in April of 2002. Getting these segments on orbit and getting them assembled and all of the power systems and thermal control systems that are embedded within them up and running and close to their assembly complete configuration are absolutely key to allowing us to move into this next phase of assembly that will start with the addition of the Harmony module. We still have some forward work left to do on this truss. The relocation of the P6 module is something that we're going to accomplish during the 10A mission here next month. That will have that particular module being relocated outboard of the P5, and we will re-extend the solar arrays that we retracted during the Flight 12A.1 and 13A missions earlier, late last year and earlier this year. Also, next November, we will launch the S6 module that will give us the final set of solar arrays on orbit, and again, we're looking forward to getting our full capability for solar arrays on orbit next year. Could we go to still number 2, please? Thank you. Our ISS crew, our commander, Fyodor Yurchikhin, and his flight engineer number 1, Oleg Kotov, today they are spending their 160th day aboard the International Space Station. They will remain on board until they depart in their Soyuz capsule on October 21st for their return to Earth. At that point, we will commence Increment 16 operations with our commander, Peggy Whitson, and her flight engineer number 1, Yuri Malenchiko. Our flight engineer number 2, Clay Anderson, today is spending his 98th day in low Earth orbit aboard the International Space Station. As you might recall, he replaced Sonny Williams on the 13A flight in June, and Clay will be returning with the STS-120 crew and be replaced by Dan Tawney to start his stay aboard the International Space Station. The crew is doing very, very well, in good spirits, and eager to help us get the configuration ready to support STS-120 next month. All the systems aboard the International Space Station are operating nominally. For those of you who recall back in the Flight 13A mission back in June, we had some fairly significant problems with the Russian computer systems, and I'm happy to report that through some very extensive troubleshooting, our Russian colleagues have been able to diagnose the source of that problem, and were able to launch some additional hardware during their 26 Progress, or the Progress number 26 mission in early August. And since that time, they have been able to do the necessary vehicle maintenance to return that computer system to its nominal configuration. So at this point, we have very high confidence in the stability of the Russian computer system and feel very much like this problem is now behind us. Our preparations are already underway on orbit for the arrival of Discovery in late October. In fact, one of the tasks that we needed to get accomplished has been accomplished, and that was the relocation of the pressurized mating adapter number 3 back in late August 30th. I think we have some video of that. if we could show that. We needed to move this particular pressurized mating adapter because it has been located on what will be the temporary home for the Node 2 Harmony module when it's delivered on STS-120. So we relocated this PMA-3 to the Node 1 nadir port. That task happened flawlessly, and I can tell you that we are working no significant issues as a result of accomplishing that particular task. The next task that's still out in front of us to get accomplished between now and STS-120 is the retraction of the solar arrays on the functional cargo block. The functional cargo block is the module that most commonly we refer to as the FGB. I think we have a small simulation of that, if we could run that. As you can see, when these solar arrays retract, that will provide us with the necessary clearance that we need to be able to extend the thermal radiator panels that we will be extending during the STS-120 mission, as well as into the stage. So in order to clear up an interference issue, it's important that we get those arrays in, and we're working with our Russian colleagues today to try to get that in the schedule and get that part of the mission accomplished. So from an on-orbit perspective, the crew is in very good shape. The vehicle is currently in a good configuration, and we still have some forward work left to do between now and STS-120, but we feel good about the runway out in front of us and our ability to go get that work done. As I said earlier, we're very excited about the launch of 10A. The arrival of the Harmony module really sets the stage for a series of shuttle flights between now and next spring that will finally allow us to realize the full benefit of this international partnership, not just here on the ground, but also in low Earth orbit, and that's something we've looked forward to for a very, very long time. I'd like to spend the rest of the time with you this talking kind of at a 10,000-foot level, giving you a perspective of what lies ahead of the program between now and the spring of next year. If we could go to the video sequence, please. It starts with the arrival of Node 2 on STS-120, and right away you see the impact of the partnership. This particular module was built by an Italian aerospace corporation, Alenia, as part of a barter agreement between the European Space Agency and NASA. Here you also see on STS-120 the redeployment of P6 solar arrays in their permanent configuration. This starts us into stage 10A, where we will embark on a series of spacewalks and robotics activities that will having us move the PMA number 2 on the forward lab incone around to the Node 2 axial port, and then moving that entire stack of Node 2 PMA back to this permanent home on the forward incone of the lab. In December, and so you'll see these thermal radiators I talked about pop out there. They are. In December, STS-122 will deliver the European-built Columbus module, bringing some additional capability for the partnership. STS-123 will bring the Japanese-built experiment logistics module, sits atop of the Node 2 temporarily, and the Canadian-built special-purpose dexterous manipulator, which gives us some capability to do extravehicular robotic maintenance, which we're looking forward to. After that, we will welcome STS-124 with the Japanese module, Kibo, which again provides us additional laboratory capability. And so as you can see from that final picture, we are truly entering a new phase of this ISS assembly sequence, and we're very, very excited about the opportunities that lie ahead with getting the Harmony module on orbit, the opportunity to get us a step closer to our permanent 6-crew operation state, which is something that is going to occur in the May 2009 timeframe. We're excited about the opportunity to get these additional pressurized elements and increase our ability to do more science and utilization in support of the vision that's been put forth to us. And probably most importantly, it's this opportunity to fully realize the benefit and the value of this international partnership that has worked so well for so long here on the ground, and to get that partnership fully deployed on orbit. And with that, I think I'll hand it back to James and stand by for any questions you might have.
Thank you, and we'll start with questions here at JSC before we go to other NASA sites. Mark?
Mark Carreau from the Houston Chronicle. For Kenny, Todd, I have a couple of questions. Can you talk about the FGB solar array and what sort of timing you need? Does it have to happen before 120 can launch? And then if you could also talk about the P6 and the redeployment, any issues and that you anticipate with that because of past experience, and the timing of that. Will that need to occur during the 120 mission? Thanks.
Okay. Well, the FGB solar array, as I said earlier, we have to get those solar arrays retracted in order to deploy the radiators that we'll need to be able to dissipate the heat that's going to be generated when we get these new pressurized elements up and running with their thermal, with their systems. And so at this point, we are engaged with our Russian colleagues to get that on schedule before STS-120. Again, the critical path is to ensure that we get them folded in before we try to deploy these radiators. During the flight itself, our plan right now is to just deploy the starboard thermal radiators and to deploy the port radiators during the stage. The reason we're not doing both is primarily having to do with some robotics activities associated with the fact that the Node 2 will be sitting on the port, and we'll be maneuvering around it trying to do our activities there. So it's best if we just wait, do all the activities we need to do with Node 2 in the stage, and get it moved out of the way, and then we can deploy the port side thermal radiators. So that's our constraint. Do we have some margin to wait longer past STS-120 to deploy those thermal radiators? That's something that we're looking at, just to try to understand, where's the cliff at, if you will. But at this point, we're working very hard and put preparations in place to make that happen before STS-120. As far as the P6 redeploy, certainly we had some difficulty with the arrays and getting them retracted during the 12A.1 mission, not as much during the 13A mission because we incorporated our lessons learned. I will tell you, into this flight, I personally don't know of a lot of issues that people are expecting with that. The robotics, while complicated, are things that we can accomplish and have been able to do so successfully in our training activities. We don't anticipate a lot of issues with the actual deployment of the solar arrays itself. However, we have put time in our schedule, if required, to have some help with an EVA to go ensure that we get those solar arrays deployed during the STS-120 mission. But again, we consider that a contingency type of scenario, but what we are prepared for it if required.
Yeah, thank you. I had a follow-up for Wayne Hale. The work that you'll do on this mission with the tile repair using the caulk-like substance, where does this sort of lead you down the road on shuttle missions? Is this going to make this material more available to you on any mission, or are you focused on one mission like the Hubble repair mission, where you may have less capability to inspect and repair and analyze potentially?
The real reason for doing this demonstration on this particular flight, or I should say an early flight, is there are some questions about the material properties that can only be answered by a demonstration in space, in the zero gravity, in the vacuum. We've done basically all the testing we can do on the ground. It looks very good on the ground. We've used it in the vacuum-based glove boxes, and it looks very good there. But until we actually do a demonstration in orbit, with several simulated damaged tiles and bring those back to see how well it filled, what size the bubbles were, how well it adhered, all those kinds of questions. We don't know for sure, so this test is actually a confidence builder. We think that the tile repair capability will work as we have it today, but we'd like to be able to go forward in the future with a higher degree of confidence than perhaps we have had to date, and that's why we've ordered these tests.
Tariq?
Thank you. Tariq Malik with Space.com and Space News. For Wayne, you mentioned earlier that there's definitely some margin in your schedule to complete the station by September 2010. I was curious, with the bracket fix in place, where you are now in terms of the December flight, and I guess what the status is on that fuel tank itself.
Very good question, Tariq. You know, we've always had a little bit of a problem with the December flight of STS-123 because 122, pardon me, got to get my numbers right, because we've been in the process of repairing the VAB doors that face the launch pad on the east side of the building. You know, we really neglected that building for about 40 years. We built the VAB back in the early 60s, middle 60s, and basically did the minimal preventive maintenance in those big steel doors and the rollers and mechanisms, basically set facing the sea breeze for 40 years with that salt spray air, and had corroded quite badly. And about 3 or 4 years ago, to come up with enough money to refurbish those doors, and we actually got into the mechanisms and found that it was in worse shape than we had predicted they would be, so it's taken us longer to get the doors fixed. During the time we've been working on those doors, and anybody that's been at the Kennedy Space Center and looked out at the VAB knows we've had scaffolding on the east side for quite a long time now. We have been limited to one integration cell, one location where we could stack the solid rocket boosters in the external tank, put the orbiter on, and that becomes a bottleneck in our processing flow. We are wrapping up the work on those doors right now. As a matter of fact, they're going to be done a couple of weeks earlier than we had projected. We projected November 1st, and we'll really be wrapping up here in September and be able to start stacking in the second high bay on or about the same time we roll Discovery to the launch pad. So this has really allowed us the margin we need to ensure that we can get the December flight off on its scheduled date of December 6th. The schedule will still be tight, but it certainly has provided us the capability to address that launch window with a great deal of confidence. So barring some unforeseen circumstance, I feel very confident we'll be launching STS-122 on December 6th.
And then just as a really short follow-up, based on, I guess, the changes you'll have to make to the brackets on that tank too, do you have estimates on, I guess, how long that would take once it does arrive at the Cape and when that's
right? Yeah, yes. We about 3 tanks down the road. We have a complete design. We're changing these brackets that had the little foam loss on the last flight. We're changing the brackets out for titanium brackets, which have a better heat transfer characteristics and require much less insulating foam, almost none, but not zero, but almost no insulating foam on those brackets. In the interim, we've decided to modify the tanks that don't have the titanium brackets but still retain the old aluminum brackets that require a great deal more insulation. We'll be doing those modifications at the Kennedy Space Center as we did this last tank's modification at the Kennedy Space Center. That's all built into the schedule. We know the techniques, the drawings and engineering are all complete. The workmen have had their training, the guys that are actually going to do the work. And we'll be traveling to Kennedy Space Center from the New Orleans area to do that work, and it's all in the schedule, and I don't see that being a problem for us.
Okay, Gina?
Gina Sinceri, ABC News for Wayne. When you talk about changing plans for Atlantis, I'm not sure what you mean.
Well, we have a baseline schedule right now that says we will retire Atlantis after the Hubble mission next August, July or August. And And that's in part is a money savings activity. You know, it goes to workforce at the Kennedy Space Center. It goes to spares that we have to have at our logistics depot. If we only have 2 orbiters that we have to maintain in flight-ready condition, we can get by with fewer spares and actually allow our workforce to attrit somewhat. However, if we feel that we need the schedule margin, that vehicle is a perfectly flyable vehicle, and we would go back in for the spares, and we would keep our workforce on task, and that would allow us considerable schedule margin. However, we're not going to exercise that option for some months yet. We're going to see how we do through the rest of this year before we think about changing our plans to fly Atlantis more. Right now, Atlantis is scheduled to retire, become a donor vehicle, if you want to think about it, after the Hubble flight next summer.
Kate?
Yes, it's Kate Tobin with CNN. This is a question for Wayne Hale. You mentioned a new procedure for flight readiness reviews starting with this launch. Can you give us some more detail? How long has that been in work? What prompted it initially? And you indicated at the executive level that there's going to be more independent review. Who will that be, and what exactly will they do?
There have been a number of different reasons to change the flight readiness review. You know, the shuttle flight readiness review is probably the granddaddy of flight readiness reviews, and over the years a number of programs have had what we think philosophically are probably better reviews, and in looking at those, we decided that as an agency, at the highest levels of the agency, we should have a more thorough review for the program manager, because as you know, we are a multi-center program, and sometimes the program manager doesn't really get to see everything before it comes to the flight readiness review, which is probably not what you really like. So we've added in a full 2-day, day and a half to 2-day review at the program manager level from all elements, and then we will summarize the outcome of that to the executive level about a week later. And at the executive level, we'll have not only the Associate Administrator for Space Operations Mission Directorate, which is Bill Gerstenmaier, but we'll have the Associate Administrator for the Exploration Systems Mission Directorate, Rick Gilbrick, in attendance, as well as what I would call the independence of the institutions, the 4 center directors for human spaceflight, that is Johnson Space Center, Marshall Space Flight Center, Kennedy Space Flight Center, and the Stennis Space Center. Center directors, as well as the NESC, the NASA Chief Engineer's Office, the Office of Safety and Mission Assurance, and the composition of the board having changed, it will be more the burden of the program management team to present our readiness for flight rather than we all go down and get educated together. So I think this will make a better review. It will allow people perhaps at lower levels to participate more completely. You know, we continue to look for ways for folks at the lower levels to get their inputs in. I am particularly interested in dissenting opinions, people that have concerns that perhaps were not completely addressed in the normal chain of command, being able to come forward to the flight readiness review at the program manager's level at the very least to state what their concerns are so we can perhaps address them more appropriately. So overall, I think this is going to be an improved process. We are taking it out for a trial run for STS-120. We'll see how it works. I suspect we'll be pleased. Obviously, we wouldn't be doing it if we didn't think it was an improvement. And assuming that we like the way it works, we'll keep doing it that way for the duration of the shuttle program.
Thank you.
Go back here to Todd.
Todd Halverson of Florida Today for Wayne. I've got 2. First of all, in the December mission, could you update us on what your window is? I think your cutoff was the 13th for beta angle, and when you would have an opportunity to launch if you did not make it in that time, and whether you would fly during a year-end rollover.
Yeah. All very good questions, Todd. Right now, our launch window starts on December 6th and ends on December 13th. As you're well aware, the solar angles require, we get to a level at which literally we cannot both protect our thermal limits and generate the proper power for the space station at the same time. So we have a cutout of about 2.5 weeks that we would not want to launch until the orbit processes around and you get better sun angles. I believe that we would technically be ready to launch from the beta angle constraints on December 30th. We have worked very hard to be able to fly over a year-end rollover. However, we do have some concerns about year-end rollover and where that falls with regards to critical activities. And we said, for example, we were not going to make the investment at the Kennedy Space Center to be able to launch over a year-end rollover. So our current thinking, and this is not really cast in concrete, but our thinking is that we would wait until after January 1st, probably the 2nd or 3rd, before we would consider launching. When you do that, of course, then you have a lot of folks working the holiday season, and we need to think about our workforce and what their schedule is and whether or not we want to work them through the holiday season. If you wanted to avoid that impact to the workforce, then you'd be looking at something like the 15th or 16th of January. I think my druthers right now would be to try to go ahead and get off on the 2nd-ish, but that decision is ahead of us. We have not discussed it at all. Those are just kind of the parameters that we're thinking about, and of course I remain optimistic we'll get off on December 6th and not have to worry about this at all.
Thanks. And on a different subject, I believe you've been working on a human capital plan for the transition from shuttle to the Constellation program, and I'm wondering if you could provide us with some details on what type of incentives you might be putting in place to keep contractors on board through wheel stop on the last shuttle mission and then the retention of critical skills through the gap.
That is number one concern that I have as a program manager. We rate all our risks. Some of them are technical, some of them are schedule, some are financial, so on and so forth. My number one risk that I consider for the Space Shuttle program is the retention of critical personnel to the end of the program. We definitely have a challenge ahead of us. We've done a lot of benchmarking. Folks who have gone out of business, for example, the Titan program, went out of business, and what they had to do to retain people. We're working with each one of the contractors, and we've got a number of prime contractors as well as the subs to work out retention plans. I would tell you that they vary by contract. Without a cheat sheet right off the top of my head, I'm not sure I could give you all the details, but there are some financial incentives and other incentives that are available from each contract. Obviously, we have a large workforce at the Kennedy Space Center that I know you're interested in, being from Florida, Todd, that we want to retain to the very end of the shuttle program. There is a follow-on set of work with the Constellation program, and we're working very hard to align our contracts and our mechanisms to retain people with the Constellation contracts and mechanisms so that people see that they have a future in the industry. I think that is what all our surveys tell us is the number one way to retain people is to show them that they have a future in the industry. So there will still be a large number of jobs in Florida in the space business, as you know, a large number of jobs with the Constellation program, with the Ares 1 and Orion programs. And we're working hand in glove with Constellation to define a path for workers to transition from the shuttle as we retire onto Constellation as they step up to start their first test missions starting in 2009. So I think we've got a pretty comprehensive set of plans. I'm not completely satisfied that we've covered all the bases. We're going to continue to work very hard on that. And as I've told you, in terms of management attention, it's the number one thing on my radar screen, even above foam coming off the external tank, is how do we retain our critically important workforce with these skills and these capabilities to the end of our program and make sure that they have a place to go and are not left out in the cold when the last shuttle comes to wheel stop.
Bill Harwood, CBS, with one quick one for Wayne and two quick ones for Kenny. But for Wayne, you mentioned Atlantis, and I thought that OMDP played a role in when Atlantis had to go into space. So how do you fly past that point if you decide you need to, number one? And for Kenny, is there any update on the port CBM status on Node 2, because of the indications you had when you took off PMA 3? Is that resolved? And then I had one follow if I've got time.
When we put the orbiters in for heavy maintenance, it's like taking a large aircraft in for what they call a C-check or D-check, heavy maintenance. We do a lot of structural inspections to make sure we don't have corrosion and a number of areas. We do a lot of inspections of wiring to make sure that we haven't damaged wiring, which has been a real problem not just for the shuttle program but for the whole aerospace industry. And we do a number of component black box checks where we actually run the black boxes through electronic checkouts to make sure that they're working properly, as well as mechanical and functional kinds of things. Looking at Atlantis, I've challenged the orbiter team. We have basically been doing structural inspections all along, so we think we're going to be in good shape and not require a heavy maintenance period to do the structural inspections where we need to fly Atlantis long. Basically are complete with the wiring inspection. There's some fraction that we would probably like to do, but could do in a long turnaround period. The black box checkout we're doing on a regular basis now, and finally the mechanical checks. Again, if we had a long flow, we could probably work those in. So I feel confident that without taking Atlantis out for a year-long heavy maintenance period, which has been our tradition for the last decade or more, we would be able to fly Atlantis out to 2010 if we needed to. The question is, do we need to? Do we need to make that investment? Do we need to keep that workforce engaged? Do we need to spend those resources? There's not a huge amount of resources, but again, if we don't have to spend them, and prudence says we shouldn't. So we put our plans together. We know what we need to do. We know how much schedule advantage we would gain from doing that, which is about 3 or 4 months. But we haven't pulled the trigger on that, and if the schedule continues to go well, we won't.
Let's see, Bill, relative to the port CBM issues that we had during the PMA 3 relocation, I think you meant on Node 1. Yeah. The issue was we had a couple of the bolts that indicated a fault load indication. We had another one that was acting erratically. We chose to go ahead with the sequence based on what the signature we were getting. Subsequent to that, in fact, just within the last few days, we've run what's called a built-in test on some indicators to see if they cleared their fault load indications, and indeed 2 did clear. And so at this point we are dealing with one that still shows a load indication fault, which gives us really a measure of the torque for that particular bolt. And so we've still got to go do some more troubleshooting on that to see if we can get that indicator to clear. But at this point, we have a backup, just as we used during the PMA 3 move, which is to use the current as a good indicator of what's going on relative to the torque and on the bolt itself. So that was an existing procedure, and so we used it during the PMA 3 move. We'll be prepared to use it again during the Node 2 location or installment over onto Node 1. And I guess just as another fact, if you will, we only require 15 of the 16 bolts anyway to ensure that we have a good mate. But again, we have the procedures in place that regardless of what this fault load indicator does, we're going to attempt to try to clear it again. But if we don't, we have procedures in place that allow us to get that bolt engaged and where it needs to be.
And one quick follow-up about P6. You mentioned, the EVA guys will be able to help and do some assistance there. But structurally, if you go to deploy these arrays and one or both didn't get all the way out, I'm not, I mean, I don't know if the arm can reach that if the EVA guys had to do something, but structurally, what are you good for and what are you not good for if you have a partial deploy on one?
Okay, I assume you mean relative to other dockings of other vehicles and so forth.
What you can live with if it doesn't deploy fully as you obviously expect.
Sure, understand. And to be honest with you, I'm probably not the right one to answer that particular question. A couple of the guys coming after us will probably be able to give you some more insight on what analysis we've been able to do to clear dockings of progresses and so forth. But again, we feel like from a procedural standpoint, based on our history with these arrays, that if we don't get them out, that we understand enough about the robotics and the EVA activities that we'll need to do to get them back out to their full extension. So I would ask you maybe we'll defer that question, and if it doesn't get answered, then I'll make sure we get an answer for you.
Okay, and I think we'll go to other NASA sites for questions now, beginning with NASA headquarters.
Tracy Watson, USA Today, for Wayne Hale. I'm wondering if there are any specific incidents or anecdotes you can tell us about things that would be solved by this new FRR structure. Does anything specific come to mind? And then I'll have a question for Mr. Todd, too. Thanks.
Well, Tracy, I don't know that I have any specific incidents or anecdotes, but I will tell you we're always trying to improve our processes. We're trying to be a learning organization and take into account the best practices of other organizations. So we're continually trying to get the right information to management, the best information to management, and a complete story so we can make really good decisions. And that requires, I think, a lot of thought and an occasional rejuggle of the way we do things. So we're trying very hard, Tracy, to improve our process here and allow for information to come forward so that we remain as safe as we can possibly be in this risky business that we're engaged in.
Okay, thanks. And for Kenny Todd, I'm wondering why you don't want to wait to redeploy the radiators. Do you need their capability for Node 2's operation itself? And also, why is there any negotiation with the Russians on retraction of the FGB panels? Is there some kind of problem or obstacle for them to doing it before STS-120?
Okay. I guess I'm trying to understand your first question, Tracy. Was it relative to the thermal radiators and when we're going to deploy them?
I believe you said earlier that you would like to deploy the thermal radiators for heat disposal, at least one of them during 120, and you were thinking about whether you could put it off, and I'm wondering why that is. Is it because Node 2 itself needs that capability?
The reason, again, what we're trying to do between now and 120 is retract these FGB solar arrays, and it's all clearly due to an issue for when we deploy these thermal radiators. Let me start with your last one, and then I'll see if I can work back to your first one. We're working with our Russian colleagues right now to make sure that we have all the appropriate activities and plans in place and our operations identified that will allow us to be able to continue to provide power to the FGB. Once we retract those solar arrays, then our Russian colleagues will be dependent on us to get their power. We currently today supply power across that interface, but again, we are just continuing to work to refine our operations and our plans to ensure that when we retract those solar arrays, that we won't have any holes in our process or our procedures that will preclude us from ensuring that we can provide power to the FGB. And so our Russian colleagues are certainly holding our feet to the fire with that regard to make sure that we can prove that we can do that. And so we're continuing to work with them to make sure that we can get them comfortable as well as our own management. So that's the task before us. And again, I would say we understand all the activities that we need to do. to get everyone comfortable with doing that retraction. And at this point, we're on track to try to accomplish that at the end of the month, at the end of September. I believe our date is September 28th today. As far as the reason, once we get the solar arrays in, we'll be able to then deploy during STS-120 the thermal radiators. And again, our plan is to deploy the one on the starboard side because we can. We don't want to deploy the one on the port side, again, because we're going to be doing some fairly significant robotic operations in that area with Node 2 immediately after the docked operations with the Space Shuttle on Flight 10A. We'll go into the stage, we'll do these spacewalks and some robotics activities, and just from a logistics and moving around in that general area, it makes more sense to say let's wait and deploy the port thermal radiators once we get out of that area with the arms. So that's what we're doing. As far as our ability to do it on deploy the starboard radiator during 10A, getting these solar arrays retracted is a critical path item for that. So again, we understand what that work is to go get comfortable with doing that task, and we'll have to deal with the consequences of pushing both of those deploys into the stage if for some reason we can't get to the point during the STS-120 flight where we can deploy both sets of radiators. But again, the plan in front of us is to go do the work with the FGB solar arrays on September 28th, and we're working very hard to make that schedule.
Can't believe that's all the questions from NASA headquarters, so we'll go to the Kennedy Space Center now for questions.
Yes, this is Marcia Dunn of the Associated Press with two questions for Wayne. I'm wondering if you had already on schedule a testing of the on one of the future flights, and if so, when would that have been?
I'm sorry, Marcia, I didn't understand your question. The testing of what?
The caulk gun with the TPS repair that will be tested on the next flight. Had that been scheduled in a future mission, and if so, when would that have taken place?
We had it scheduled for the STS-126 flight. We reviewed the maturity of the TRAD, the acronym. I'm trying to think of what that stands for right off the top of my head. The tile repair applicator device and the material. We are significantly more mature than we had originally thought when we put that schedule on STS-126. We also looked at the capability to add an EVA and a test to STS-120. Again, if everything goes well on STS-120, it will fit. So it gave us an opportunity to do a test several flights earlier than we had originally planned. I would caution you that we have not had an agreement with Space Station program. Kenny's probably hearing about this for the first time. So we have to have that discussion Monday. And we also, if we have any difficulty at all deploying the P6 solar arrays or any number of the other robotics and EVA tasks, we would default back to a later flight for that test. But it seemed like it came together. If everything's going well, we can get the test in on 120 and get our confidence level built to its high level earlier than we had expected.
Thank you. And my second question is, with the changes in the FRR, and there still is talk within NASA about culture problems, and I'm wondering where you sit, do you get the sense today that people are still afraid to speak up about problems?
We have instituted a number of ways for people to speak up anonymously. And we have received a number of inputs through our anonymous channels, even in the last few weeks. So, I would like to say that everybody feels comfortable coming to a board, standing up in front of the management and presenting their case, but apparently that's not so. I know that we work very hard at the upper levels of NASA management to ensure that all the supervisors and all the managers would not take action against somebody that brought forward a dissenting opinion. We're encouraging dissenting opinions. We're just encouraging the proliferation of ideas and information. But apparently there are still some people that are concerned that there might be retribution if they speak up, which to me is a sad thing and an indication that we still have work to do. But I will tell you that I think we have made improvements, and it is certainly better than it was 5 or more years ago. It is one of those human element sorts of things that will require continuous management attention, and I don't know that you can ever say that you have succeeded, but we can certainly move toward the goal of ensuring people are not to speak out, and will bring their concerns and opinions and information to the higher level of management if they feel that they haven't gotten a fair hearing, from their immediate supervisor or in the lower levels of the organization.
And I believe that's all the questions from Kennedy, so we'll come back here for a few more. We have them.
Mark Carreau from the Houston Chronicle. I have a couple, I think, for Wayne Hale. First, I'd like to follow on Marcia's question, and I'm wondering if this restructuring, in a way, addresses this culture issue. Are some people maybe more willing to speak up to you and managers at your level in this management review than they might be to the top man? I'm just trying to figure out why this change fits into this. Where the change fits in this issue.
Well, that's a very good question, Mark, and I would tell you that there wasn't any one incident that drove this change. It's been a serious thinking of the management over the last several months that we need to continue to improve our capability to hear people. And it is a natural phenomenon that people will speak up more freely and with their peers than they will with the higher level of management. And the higher level of management you go in the management chain, the more people seem to be socially inhibited from speaking up. And we deal all the time with rather introverted engineers, I've got to tell you. And sometimes it's really hard to get them to talk, no matter how hard you work at it. They're really good, but they're not very verbal, and they're not sometimes very forthcoming. So we're in a continuous effort, again, not because they're afraid to, but because that's, basic human nature, personality. Sometimes I feel like I should have gotten a degree in psychology rather than engineering. But we're trying as best we can to help people express their concerns and bring forward the right information. And I would say this is just another one of our steps in continuing to try to improve that process.
On a little different topic, if I might, it has to do with your thinking on Atlantis. If you know what kind of savings retiring that early gives you, that'd be nice to know. But I'm wondering, what kinds of issues are you looking at? Is it more than just the storm? And by that I mean, on the last couple missions, you worked, I think, during the flight with engineers to determine whether you might have structural damage because some of the tile. If that sort of happened and caught you by surprise, and you had an orbiter that didn't have an ohms pod or had a weak point in the structure from some overheating, and you had to sort of think about, is that the kind of thing you're talking about? Or, I'm just not sure what would drive you to the point to keep Atlantis, and what you say by taking it out if you can.
Well, okay, there are any number of reasons. We talk about weather because that seems to be the one we worry about the most. But yes, you're right. There could be any number of damages, whether from ground handling or in flight or any number of things that could cause an orbiter to need a longer period of repair than we would like to have as we come toward the end of the program. So keeping Atlantis in a ready state, or actually flying Atlantis, would give us 3 orbiters when we really only need 2 at about a year from now to complete our manifest, would provide us margin. Now, we don't necessarily have to exercise that option right away. We would, in fact, like to be good stewards of the taxpayers' money and not spend money that we don't have to spend. Now, that may sound like some kind of odd statement coming from a government bureaucrat, but that's what we'd really like to do, is be good stewards of the taxpayers' money and save some. actually pass it along to Constellation, perhaps, so they could make use of it, or what have you, because that's what we really try to do: be good stewards of the taxpayers' money. At the same time, if we're successful and we don't have problems, we don't need to do that. But we're trying to lay out different management options. There are all kinds of management options that we could take. Some cost money, some have impacts to Constellation, some are basically free, but we're trying to give ourselves the margin and the capability to accommodate unforeseen circumstances and still complete the International Space Station by the time we've been asked to retire.
Okay, we'll go over here with Kate.
Kate Tobin with CNN. Question for Wayne. This is back to the tile repair issue. I remember when you folks were actively preparing to return to flight, quite a bit about the TRAD and the STA-54 goo at that time, and the decision was made not to test that on either of the return to flight test flights. You tested the NOACs and the emittance wash, but not the STA-54. What has happened between then and now? Has the applicator been redesigned in some capacity? Has the recipe for the STA-54 been changed? Is there anything different now about that material and that procedure that was not the case prior to the tests on the return to flight test flights?
Good question, Kate. Yes, we have completely redesigned the applicator. We had something called a SIPA applicator, which was a much bigger device, actually took 2 crew members to operate. And now we have the smaller device, more like a caulk gun, good analogy, that would repair a rather smaller damage, but more typical, perhaps, of what we've historically seen. So we have a much smaller volume with a different device. It's now pressure-driven and so forth. The material itself hasn't really changed, but our understanding of it has changed. Early on, the toxicologist pointed out that under certain circumstances, one of the 2 components, this is a 2-component, like an epoxy that mixes to provide its hardness and curing. One of the components had the capability, if it settled out, to become toxic and release some toxic vapors. One of the things we were very concerned about on STS-114 and STS-121 was this concern about toxicity. Now we have a much smaller volume of the material and it's much better mixed, and we have done some studies and understand that it takes a long time on the shelf for this part to separate out and become a toxic hazard. So we're much less concerned about toxicity. One of the big reasons we didn't actually do a demonstration, well, there are a couple of reasons we didn't do a demonstration. Number one, we used all our time available for TPS repair demonstrations on what we thought were higher priority, which is to say the reinforced carbon-carbon repairs, the NOACs, and the plug, as well as the emissivity wash, which is a much simpler, although less capable tile repair operation. We used all our time, first of all, on those, and then we had this toxicity question on the STA-54. Now we feel much more confident about toxicity. We have a much improved and smaller applicator, so that the ground testing is just about finally complete with everything that we think we can do on the ground. So the time has come to do an in-flight demonstration and see how it really works. One of the big things we remain concerned about is bubble size. You know, there's a gas-like component in this mix, and if you'll remember, you know, basic high school chemistry, ideal gas law, PV equal nRT. If you lower the pressure, your bubbles will become larger in volume, and the fact of the matter is, on the ground we can only achieve a certain level of vacuum, and in space you actually achieve a higher level of vacuum. So if you have a bubble problem, which we don't think we do, but you can't really prove on the ground, bubble problem, we'd like to find that out in a test in the actual conditions in space before we were faced with actually having to use it. We think it'll work. But again, there's nothing like demonstrating it at the actual use conditions, temperature, pressure, and in a zero gravity, to see that it really will work. And that's kind of the icing on the cake to make sure we have a really good repair capability that we have an outstandingly high level of confidence in. I would say we have a high level of confidence today, but to really top it off, we need to do this on-orbit demonstration.
Todd?
Todd Halverson in Florida today. If I could go back to your human capital plan for a minute. You mentioned financial incentives. I was wondering if you could give us a range, or are you talking about offering critically skilled workers an extra 3 months pay, 6 months, 1 year? I'm just trying to get a sense of what you're talking about there. And also, I'm wondering if there are certain critical skill areas, certain subsystems where you have determined that you might lack depth at this point.
Well, I would say one of my critical skills areas is deputies in the shuttle program, because they keep getting hired away to different management jobs in the NASA structure. You know, I've lost 2 deputies in the last 6 months, one to become the deputy center director at Marshall and one to become the associate center director at Johnson Space Center. So one of the critical skills I'm very worried about is management skills. They're leaving me alone. I have to hire new managers to help me out. All that aside, we have a variety of financial incentives that vary from contract to contract. And Todd, I would be, and my memory is not good enough to give you all the details, but it's along the lines of what you say, some number of extra months pay for a number of years of service and in a critical position that we're providing in general across the contracts.
Bill Harwood again for Wayne. A real quick one on TPS repair. I may be wrong, but my memory of past manifest and where 126 was that originally before Hubble, or maybe not? Then what does this have anything at all to do with Hubble? I mean, having the need to have a demonstrable repair technique for that flight.
Well, look, Hubble is unique because we don't have a safe haven. You're not at the space station. You don't have friends and air and food and water and tools and stuff where you can hang out for a long time if you get in trouble. So we're doing a number of things for Hubble. And obviously, associated with those things is we would like to have our repair capability in their best possible shape. That really didn't factor into this decision to do this demonstration early, because we have just arrived at the right place and time and we have the opportunity, so we need to take advantage of it. But yes, it goes to a general kind of philosophy that we would like to be in the best shape we can possibly be for the Hubble servicing mission, because it, by the nature of it, has a less robust capability on orbit.
Okay, I believe that's all the questions. A few programming notes. Immediately after this briefing, we'll replay B-roll that will be from all the briefings today. Then the next briefing will be at 9:30 a.m., an detailed overview of the STS-120 mission. At 11:30 a.m., we'll have an overview of the spacewalks planned for the flight. And at 1 p.m. will be a press conference with the flight crew. Reminder also that you can find more information on STS-120 and all the shuttle missions upcoming at www.nasa.gov. Thank you.